Hello everyone, welcome to my video. This is Basics of Electrostatics Part 2. I hope you have all watched the Part 1 video. In the previous video, we have seen about what an electric charge is and how it produces an electrostatic force and how it is reason for the electrostatic field and how this field is measured by electric flux. And at last, we also saw about the relation connecting charge and the electric flux. I hope you all remember the equation, that is Gauss law is equal to Q by epsilon 0. We also saw about several types of charge distribution like linear, surface and volume charge distribution. In this video, we are going to see about the applications of Gauss law. Applications applications of Gauss law. So the obvious application of Gauss law is to commute or to give the equation or calculate the electric field due to symmetric charge distributions, So this is the important and the most predominant application of Gauss law. So this calculation of electric field is restricted if and only if the system is symmetrical. So there are three types of possible symmetrical organization. First is spherical symmetry. The second one is planar symmetry. And the third one, it is called the cylindrical symmetry. Each and every type of these symmetries are associated with a particular charge distributions. In the previous video, we saw about three types of charge distributions. That is the linear charge distribution, where the charge is given by Q is equal to lambda L, where lambda is the linear charge density, and the second one was surface charge distribution, where the charge was denoted by Q is equal to sigma into A, where sigma is the surface charge density. And finally, we also saw about the volume charge distribution, where Q is equal to rho into V, where rho is given as the volume charge distribution. So here today we will derive the electric field of any one particular system with any of these one symmetry and one charge distribution. So let's take the simple case. So linear charge distribution. So in this diagram you can see there is a line at the center. So this is a wire that is filled with charges. So the charge distribution can be given by Q is equal to lambda L. These green lines denote the electric flux produced by it. So here we should associate it with a symmetry. So in this system particularly, we can associate it with cylindrical symmetry. So if you draw a cylinder around it, you will understand. So this system is associated with cylindrical symmetry. So in cylindrical symmetry, there are three regions, 1, 2 and 3. Here 1 and 3 are flat regions and the second one is the curved region. So if you are about to calculate the electric flux due to these three regions, the equation is given by phi total is equal to phi 1 plus phi 2 plus phi 3. So here you have to use the equation for electric flux. Phi is equal to EA cos theta, or integral of E dot dA cos theta, where theta is the angle between the electric field and the area. So in region 1 and 3, from the figure if you observe closely, you see that the angle between the electric field and the area is 90 degree. They are perpendicular to each other. So E dot dA will be 0. E dot dA will be 0. So we have to calculate the electric flux due to region 2 only is equal to integral of E2 dot dA cos 0 degree. So it will be integral of E2 dot dA. So substituting all these in the above equations, you get phi t is equal to integral of E1 dA cos 90 degree plus integral of E2 dA cos 0 degree plus integral of E3 dA cos 90 degree. So as previously said, these two factors become 0 and you will only calculate E2 dA cos 0 degree. This is the total electric flux. So if you integrate this, you will get total electric flux is equal to E integral of dA. So if you integrate this dA, you will get the surface area. Integral of dA is equal to integral of dA is equal to surface area. So more specifically, it is the curved surface area of the cylinder. So which is given by the formula 2 pi r L. So phi total is equal to 2 E into 2 pi r into L. So let's have it as the first equation for electric flux. So secondly, we should use Gauss law. Phi is equal to Q by epsilon 0. As already told, Q can be given by Q is equal to lambda L is equal to lambda L by epsilon 0. So here you have two equations for electric flux. If you equate 1 and 2, E dot 2 pi RL is equal to lambda L by epsilon 0. So now the electric field is given by rearranging the terms, that is lambda by 2 pi epsilon 0 R, that is in the direction of r cap. So this is the final equation for electric field due to a linear charge distribution. So I hope you all understood how this equation is derived. If you have any doubts, you can post it in the WhatsApp or you can comment it. Thank you.
இன்னைக்கு நம்ம பார்த்த டாபிக் உங்களுக்குலாம் புரிஞ்சிருக்கும்னு நினைக்கிறேன். நான் இது யூடியூப் வீடியோ, ஸோ டைம் ரொம்ப எக்ஸீட் பண்ண வேண்டாம், அதனால ஷார்ட்டாக சொன்னேன். இன்னும் கொஞ்சம் டீட்டெயில்டாக பார்க்கணும், டவுட்ஸ் எதுவும் இருந்துச்சு கிளியர் பண்ணணும்னா நீங்கள் நம்மளோட வீக்கெண்ட் செஷன் அட்டன் பண்ணலாம். அது போக ரெகுலராக டியூஷன் கிளாஸஸுமே நடந்துட்டு இருக்கு, நிறைய பேர் படிக்கிறீங்க. ஸ்டில் வி நீட் ஆல் ஆஃப் யூர் சப்போர்ட். இன்னும் ஜாயின் பண்ணணும்னு நினைக்கிறவங்க டிஸ்கிரிப்ஷனில் கூகுள் ஃபார்ம் லிங்க் இருக்கும், என்னுடைய வாட்ஸ்அப் நம்பருமே கொடுத்துருக்குறேன், கான்டாக்ட் டீட்டெயில்ஸ் இருக்குது, நீங்கள் கான்டாக்ட் பண்ணலாம். So see you in the next video. Bye.